Mathematics as a Philosophy of Living by Citydriver Downtempo. Mathematics is often mistaken for arithmetic. To many, it is a discipline of numbers, symbols, and rigid proofs. But beneath its formal structure lies something far more human, a philosophy of how to live with complexity. Mathematics does not promise simplicity. It promises structure. One of its most profound ideas is the limit. When Isaac Newton and Gottfried Wilhelm Leibniz developed calculus, they gave language to a subtle truth: value does not require arrival. A sequence may never reach its limit, yet its disciplined approach carries meaning. The distance shrinks. The direction stabilizes. Something becomes clearer, even without finality. Life often works the same way. We do not always arrive at perfect understanding, ideal circumstances, or complete resolution. Yet movement toward coherence reshapes us. Convergence itself is a form of dignity. Another quiet lesson appears in the absence of a closed form. Not every equation can be expressed in neat symbolic elegance. Many systems, especially nonlinear ones, resist analytic solutions. In such cases, mathematicians do not abandon the problem. They approximate. They iterate. They refine. This is not surrender, it is intellectual maturity. The world is not constructed for clean formulas. Human relationships, personal growth, creative work, these resemble differential equations without explicit solutions. We move forward through approximation, reducing error step by step. Precision emerges gradually, not suddenly. Error, in fact, is central to numerical analysis. There are truncation errors, rounding errors, instability. The goal is rarely absolute elimination. Instead, one asks, is the error bounded? Does it converge? Is the method stable under perturbation? Wisdom mirrors this framework. To live well is not to eliminate imperfection, but to prevent divergence. Stability matters more than flawlessness. A small, controlled deviation is sustainable, uncontrolled growth of error is not. Convergence may be the most beautiful metaphor of all. A convergent sequence does not leap. It adjusts, minutely, repeatedly. Tiny corrections accumulate. Over time, noise subsides and structure emerges. The elegance admired by Carl Friedrich Gauss was not flamboyant, it was economical, restrained, inevitable. Personal change operates under similar principles. Grand resolutions often fail. Small, consistent refinements endure. Finally, there is decomposition. When a problem is too large, mathematics reduces it. A matrix becomes factors. A signal becomes components. Complexity yields to structure when broken into manageable parts. If a task is overwhelming, divide it. If it remains overwhelming, divide again. Continue until the smallest actionable unit appears. Progress begins at the scale of possibility. This, perhaps, is the quiet wisdom mathematics offers. Not everything has a closed form. Not every path is linear. Not every error can be erased. But we can approach. We can approximate. We can stabilize. We can converge. And sometimes, being sufficiently close to truth, stable, bounded, convergent, is more honest than claiming certainty. Mathematics, then, is not merely calculation. It is a disciplined acceptance of complexity, and a patient commitment to refinement.